Okay, ready, so we're sorry. Number one, you need to evaluate, so put 3 in for x, all of your x's, and solve, and then, simplify all the way. So the final answer was 7. For number 2, to get this out of fraction form, multiply both sides by -4. And then subtract 8 on both sides. You get -28. Number 3, we needed to simplify, but there's a bunch of fractions we gotta deal with. So multiply 7/8 to 4/5, and then multiply it to 16 as well. So what is that? 30/28. And we'll simplify here in a second. Do some other math. So 16 divided by 8 is 2. 7 times 2 is 14. Instead of multiplying 7 and 16 and dividing by 8, in my head those numbers are too big, I just did it the other way. And then multiply across, so 3 and 10. And then here, this one's pretty easy to multiply across. 3 times -10 is -35. Simplify all of our fractions that we can, so divide both of these by 4. And this number. My fractions both have 10 in my denominator, so I don't need to get common denominators to combine them. I can just add them together. 7 plus 3 gives me 10 over 10. 14 minus 6 gives me 8. 10 divided by 10 is just 1. So all of those fractions disappear to give us nice whole numbers. Questions about those 3 before we move on to the other 2? Number 4, translate the following expressions twice the difference of a number and 9. We're multiplying 2 times whatever this is. We're subtracting a number and 9. Whatever variable you want and subtract it. And then number 5, we needed to solve. So distribute both of these. -5x, positive 15, -4x, -4. Combine my terms on the same side. So -5x, -2x, 46 to -4. Do whatever it says. So -5 minus 2x is -7x. 46 minus 4 is 42. Looking at these two sides, my coefficients are different. So I'm going to end up with one solution. Move all of your x's to one side and your constants to the other. Doesn't matter which side you do that to, but I'm going to add 4x and subtract 15. Sorry, my brain is not working. Oh, wait a minute. I pressed that. Okay, that was so good. 1.7. So positive 9 was the answer to that one. No, negative 9, because this was negative. Pretty. Questions on those two? We'll continue this part after lunch as well, but do we have any questions we can get answered before lunch about the last sets of notes? Yes. Number 3. So you were supposed to finish off the graphing notes where we talked about horizontal and vertical lines, graphing those, and then graphing by intercepts. And then start the writing notes, which was writing linear equations from a graph. Have any questions in those graphing notes or the writing linear equations from a graph? If not, when we get back from lunch, we're going to continue in the writing notes on, I don't remember what all was in the video, but we'll start here. I don't remember if that was in the video or not. You probably could have been able to figure that out where notes from before, but we'll start here and then continue on. Alright, to write the equation of a vertical or horizontal line, we need to remember our hookups. Remember, this is for horizontal lines from left and right. It has a 0 slope. And this is for y equals. And then Lux is for vertical lines up and down. It has an undefined slope. And x equals. So if we are given a vertical line, you're going to look where it's going to be an x equals. And we're going to look where x crosses the x-axis and write that equation. So this crosses it at 3. This will be the equation x equals 3. For our horizontal, that's going to be a y equals. So we look, where does that cross the y-axis? We're going to cross it right here at -1. So that will be the equation y equals -1. So for number 1, would that be an x equals or a y equals? X equals. And what does x equal here? -2. So then number 2 would be a y equals. And what does y equal here? Take the next minute, do the next 4, and then we'll come back and make sure those are right. So number 3 should be a y equals at -5. 4 should be an x equals at +4. 5 should be a x and x equals, and it's at 0, the line is on the y-axis. And then 6 should be a y equals at positive 2. Questions on those four? This next page is kind of like the same thing we did, or I want to say what's in the video. No, we did that one together. When we were graphing and we had to write the equation and then convert it, this is kind of the same thing. When we did it in graphing, it was kind of misplaced. So we're not really going to do any of these examples unless you go to this one. But I am going to fill up this top part. So you need to know what the slope-intercept form is and all the pieces and parts, so that M is slope and B is the y-intercept. And you just need to be able to recognize that this is your standard form. So if you see an equation like that, it's in standard form. Did we want to see any of these? Or check ourselves? Go over any of this side? And then did we have any questions on this side? This one through 6? Yeah. Let's see any of those. Need a refresher on those. So for number 2, remember our goal is to get y by itself. So we need to get rid of our x term by subtracting the x term to the other side. I'm going to go ahead and switch these two so it starts to look like it's in our slope-intercept form. And then we need to divide each of these terms by 5. So this would just give me y equals, this would become a fraction, negative 4/5, and then negative 6. So our equation would be y equals negative 4/5 x minus 6. Any others on that side? Somewhere at the top of this page, I know you have additional space, I don't have that much space. Write in this formula. So y minus y1 equals m, and then in parentheses x minus x1. This is called your point slope formula. And we use this when we have to write an equation and we're given a point and a slope. So for number 1, before I put everything in, I would label this. So this is your ordered pair. I'm going to label that x1, y1. Your slope is the variable m. So we have 3 different things from the formula. The one that says y and x, those are just going to stay y and x. And we're going to put those in. minus 1 equals 3, and then in parentheses, x minus 2. So we're always subtracting no matter what. Think about that like slope. And then our goal is to get this back to slope-intercept form. So we're going to simplify this by distributing. We have 3x minus 6. And then get y by itself by adding 1 to the other side. So we have y equals 3x minus 5. So anytime we're given a point and slope, we're going to use this formula to simplify it and then make it into slope-intercept form. Do we have any questions about the process? We're going to skip to number 3 because that one has negative numbers. So again, I'm going to go through and I'm going to label these. If the labeling helps you, continue to do that, but if you're good without labeling it, then you don't have to do that. And then I'm going to put those 3 things in to my formula. Y minus, I have a negative and I'm subtracting. Negative 1 and then parentheses x minus 4. Anytime you have negative numbers, that side is going to become a plus. You could do that and then distribute, or at the same time. So it depends. You're always subtracting less, but this one is also having to be negative. Always plus. But you're always subtracting no matter what. Or I should say, initially, you're always subtracting. So this negative and this minus is going to become a plus. And I can distribute this to become negative x plus 1. And then move 7 to the other side by subtracting. So y equals negative x minus 3. Our equation of the line. Any questions so far?
I'd write the formula before you start doing problems. Just write the formula out of the problems you do, and then just plug in the numbers. So you don't have to think about the formula every time. Just look at the formula, put the numbers in each spot, and then solve it. It's going to be the same formula for all of those.
We're going to do one more of these and then jump down to the bottom, and then I'll let you practice all of these. So this one has, this one's going to be the practice problem. So we have y minus 4 equals negative 3/4 times x minus 6. Distributing, we have y minus 4 equals negative 3/4 x plus, these are going to become a plus. You can multiply across, put this over 1. Negative 3 times negative 6 is positive 18. Positive 18 over 4. Can't divide that, but we can simplify it. Positive 9/2. If you're on your calculator, I'm going to If you go into alpha y equals, you can put in fractions. Negative. And it will simplify it for you. If you don't put it in fraction form, it's going to give you decimals. Alpha y equals gives you the fraction. And then the last thing we need to do is add 4 to the other side. So if you have that in your calculator up already, and it'll still give me whatever the answer is in simplified form. 17 halves. You could have also done it by hand, change the denominator. You have 8 over 2 and add those together. Y equals negative 3/4 x plus 17 halves. Would be the equation of that line. So that formula works anytime we have, or anytime we're given a point and a slope. But the bottom section, we now are given 2 points and not the slope. But we can use those 2 points to find the slope and then go from there. So starting at number 1, I would need to find the slope of this first. Remember, slope is y2 minus y1 over x2 minus x1. Label them if it helps you. And then find what that slope would be. 4 minus 1 over 2 minus 3. We get 1 plus negative 3. Once you find that slope, you then have choices of which point you can choose to use. So I'm going to show you that both work. You will not need to do both. You will just have to pick one and do it. So if I'm choosing the 0.31, this would look like y minus 1 equals negative 3, x minus 3. I would start simplifying this. Y minus 1 equals negative 3x plus 9. Add 1 to both sides. You get y equals negative 3x plus 10. But if you chose the other point instead, which is fine, I'm going to put this in this space, but it's not number here. It would look similar. The slope would be the same, but the point of no change. So y minus 4 equals negative 3 times x minus 2. Same thing. Simplify this. You get negative 3x plus 6. Add 4 to both sides. And you would get the same thing either way, whichever point you use, as long as you're doing that math correctly. Do you have any questions on that process? I am going to mention this. So for questions like number 4 and number 5, it gives you the y-intercept already. So yes, you could still put those points back in and you would find those, but it's not necessary if they give you the y-intercept. If they give you that, you would just need to find your slope, and then you could put it in slope intercept form because you have your slope and your y-intercept. Something else, as like a tip, after you find your slope and you're trying to choose which one to use, if it has a 0, I would use that one. Let's say you forget that it's a y-intercept and you just go solve it, that's fine. Go with the one that has a 0 because then you'll have less work. You have any questions on this? I know we only did one of these, but I want you to be able to show this. So for the remainder of class, you're going to be working through these examples. There's another page. Two practice problems you could do. I have a test review that I really wasn't going to give you until after the quiz, but you can definitely take it now in the back. That has additional problems to practice. I don't believe I said this at the beginning of class, so I'm just going to mention it now. Originally, I think on the calendar and in Canvas, it said that we were going to quiz today, take the test on Thursday, but I changed that because we needed to finish this. So we're going to take the quiz on Thursday, yes, which means you will need to study over the weekend because on Monday we're going to go over the quiz and then take your test. August? So you have this time to work. We'll be walking around if you have any questions. Ask if you have any questions.